Thank you very much for this kind introduction. I'm happy to be in Ottawa for the first time. And yes, we had a very nice acronym, I'll explain later, but it's of course not too difficult. Food Biomarkers Alliance, we had FOODBALL, and actually we wrote it, as you can imagine, during the World Cup, which was in Brazil at that time, and we were discussing at our airport meeting rooms, we need a nice acronym, and I went to the toilet because I thought, I don't know anything. My mind was empty. I came back and suddenly some of the guys and girls had sit together and said, we have it, FOODBALL, and everybody was so enthusiastic, so we just made it FOODBALL. Okay. Actually, this is a project, and I'm going to explain in detail, a little bit in more detail, just to give you a flavor of how this works. And this was funded by the call, this one, the call which stands for Biomarkers in Nutrition and Health. So that was one of the calls which was given out by the JPI. And in the end, 2 projects were funded, ours and another one, which is a little bit smaller, which is on microRNAs as potential markers of what's happening in the body. That consists of 3 partners. This one is bigger, and I'll show you later. But a little bit of the background, because I know a lot of nutrient expertise is here on the table. And actually, our main frustration, I tell you, I'm trained as a nutrition scientist as well as epidemiologist, so this bothers me all day, every day, I would say. We lie about what we eat, and it's messing up my work. It's messing up our work, right? So that's why, actually, my main interest comes in this type of work. And as I know, as an epidemiologist, we also work a lot with food frequency questionnaires, and you know, the 24-hour recalls, the single recalls from Anne Haynes was heavily on fire, and I understand why, because of the day-to-day variation. So actually, just to recap the current state of dietary assessment, and for me it's always very, let's say, well, I'm always a little bit disappointed to tell you that the best method I've ever come across, the dietary history, I worked with it, even in a cohort, is still the best, but I think the first paper's already dated from the Second World War time. And then, of course, we have the food diaries, and more recently the 24-hour recalls came much more popular, but they rely on memory. And of course, the day-to-day variation in our diet is getting higher and higher with the modern dietary patterns. So we need many more days to recall. And of course, that's a toll on our volunteers and also a toll on our dietitians. And then more recently, the food frequency questionnaires came up, which are more easy for the volunteers to fill in, but for us, a bigger effort to prepare, because they are population specific and very difficult to align. And especially in our European projects, we have a lot of problems with this. Because everybody, you know, who is not fully aware of the problem, just give me a call and say, okay, can I borrow your food frequency questionnaire? And they say, where are you based? Well, in Czechoslovakia, or Czechia, I should say now. Well, I said, no, that's not going to work. You have a very different dietary pattern. But this is not well appreciated across the whole board of people working with dietary intake. So this is the current status, and we know it's not perfect or not perfect at all. There are new developments. This is, well, not very clear, but this is our recall, and we can take it, we can have it filled in by the individuals themselves online. So we have online tool for taking 24-hour recalls, so that's a new development. And this is Carol Boucher, you know, you're all aware, she still works, I think, which is very exciting, but I'm not sure it's really there yet, to take pictures of your dishes and then to have an interpretation about quantity, but also what's really inside. So I'm always very anxious about to hear more about this, but I think this is also, you know, not easy. Hence, we think about the biomarkers. But oh no! Before that time, I think we can do whatever we like on our dietary intake assessment, and that takes a toll. But of course, our errors are not only coming from our error in estimating our daily intake, but also about our food tables. What is really what the nutrients in the different foods are. So this is really multiplying our error. So in the end, we have quite a lot of random error. We hope it's random, but it can also be systematic. We know people with overweight always tend to underestimate certain intakes. So actually, this is the problem we are facing with today, still. So that's why our idea is, also to use biomarkers, of course. So there can be various definitions on biomarkers. The IARC, the WHO agency on cancer, has done quite a lot on this. And anyway, it can refer to subsequent biological events or between exposure and the occurrence of disease. I'll come back to this later. So this is a slide I usually use for my students. So actually, if your exposure is something like vitamin B12, you can have various, biomarkers along the chain of the metabolism of the vitamin B12 until there's something which is called a disease like pernicious anemia. So there are various biomarkers for such simple things like vitamin B12. And actually, there are quite many for the specific nutrients, but that was not really our goal. Just to recap, we have urinary nitrogen for the protein intake, or potassium and sodium. And of course, sodium we frequently use because we know that estimates from sodium on self-reports are really unreliable because you add the sodium during cooking on the table. And we use these biomarkers in various of our study designs. The validation studies, I think, is very important, and that's preferably you use biomarkers for validating your dietary intake method. But we also monitor compliance in our intervention studies. And actually now more and more also in cohort studies with big biobanks, they can be used to assess, for example, the use plasma homocysteine level as a marker, for example, of folate deficiency. Well, there are even papers written about classifications about the dietary biomarkers. So we have the recovery biomarkers, like the nitrogen in urine, which typically a recovery of the protein in your urine. You have ones which are not really the food or the nutrient itself, but the more predictive biomarkers, like the metabolites of sucrose in the urine. Of course, we have the concentration markers circulating in the blood, but then there's always the problem, what is inside the blood? I mean, is it outside the tissue? We always call the plasma or what is the English word for afvoerputje, riool? I don't know. Well, yeah. A sewer, yeah, well, sink, sewer, yeah. What is inside your plasma? Well, something which has not been used in the tissues or, or still in the way of taking up. So what you measure as concentration in plasma is always, something somewhere in between. So we decided to go, with some newer methods. Before I explain about my project, this is some two other slides, because sometimes, and I think this is, people outside nutrition don't appreciate it very much, that if we think about a method, the perfect method, of course, has a correlation, or biomarker has a correlation of 1 with the gold standard. But of course, then the difficulty is, what is the gold standard? That is very difficult to assess in a dietary intake. Well, if you have the 7-day record, and you compare it with 8 collections of 24-hour urine. I think these data are from Walt Willett from Boston. The correlations is 0.7. So that's more or less the highest correlation you can see in any validation study. For food frequency, looking at protein and comparing it with this 8 days nitrogen, the correlation is only 0.24, which is really, really low. But, we are happy with it, right? I mean, this is really interesting. Use a single 24-hour recall, yet you can already see that the correlation gets lower. What does this mean? Well, if we use a food frequency or 24-hour recall method and relate it to a specific disease outcome, we have something like this. We observe, using our imperfect method, a distribution like this, while the true distribution has less variation, so a smaller standard deviation, so it's more narrow. So the true distribution is the black line. So that's what our real protein intake would be. And if you look at an association with a disease, the true association is the blue line, but we observe a flatter line because the distribution is wider because of the additional error in this method. So actually what we see, and that's a simple reasoning, we say, it's not bad, we just only underestimate our true associations, right? So that's the good message of this picture. But I always tell my students that this is also not really true, because if this is, underestimating your true association, also your association with confounding factors like energy or vitamin C or fruit and vegetables also are underestimated. So if you do your multiple regression, you add error on error, and then really you cannot say anymore that your true association is underestimated, because you can also overestimate it, really depending on the complex correlation between all the factors which are in your multiple regression model. So actually, this is really a nightmare if you think about it. I don't always want to forget about this, especially with the food frequency questionnaire, which had a correlation of 0.24 with the gold standard protein intake measurement, so to speak. So there's a lot of error around, which really leads us to over or underestimation, which is difficult to predict. And one of the things we should focus on more is trying to find out what this, with using measurement error models, what this impact is. Okay, then the project. Well, given this, we thought about, the ideal situation where we have the best biomarker. And so far the biomarkers which are known are usually based on nutrients, which is important. But more and more, also with the dietary recommendations, the recent ones in the US, but also the recent ones in the Netherlands, are more focusing on food, because people buy foods, they don't buy vitamin B12. And in addition, there is now this, sorry for that, developments in the lab with metabolomics, which is a nice marriage to say, okay, let's use these newer techniques and see what we can do in this field. So that is the background of the project in short. Now this, I apologize, is a little bit older slide, but these were all the countries involved in the JPI when we wrote our application. And you see we have the red stars are the members in our project. 11 different countries, 22 participants, and there is one from Canada, which is Dave Wishart from the University of Alberta. There were also some advisors and observers, because we had, for example, people from New Zealand, which were not joining at that time, but they were very interested, so we put them in an advisory board, and the same from someone from Sweden and Finland, because not all countries, they are member of the JPI, but it works this way, that not all countries sign up for a call. So for example, Finland at that time was member of the JPI already, but didn't sign up for this call for biomarkers, so the Finnish researchers couldn't participate. And I think it's very important to realize that all the money Pam has been talking about is not one single pot. It's from each country and needs to be spent in each country. So the Dutch money needs to be spent in the Netherlands, the Canadian money needs to be spent in Canada. So that is complicating things. And what is further complicated things, and now I'm just speaking as a scientist, I understand fully, I'm fully aware of all the complications, and attending the management board these days make me even more aware about all the difficulties and actually the great work which has been done so far. But as a scientist, or as a PI, I need to say, okay, so we need to report to each individual country. The midterm report, for example, which is for every country, we need to make it. And then the contracts, the negotiations about the budget was all different in each country. So we started in December 2014, but the Italians, I think, were latest. May have the complicated internal structure, I think, with several funding bodies, and they started 9 or 10 months later, officially. But then, of course, the university already paid some advancements so that they could really start together with us. But that's really showing that it's, the alignment is there, but there is still some work to be done. But that's incredibly difficult, I would say. So the aim of our consortium is to do a systematic exploration and validation for biomarkers. And these biomarkers are for food intake, not nutrients. And actually the main asset is that we use the metabolomics. And what our product will be, that was a good question, we'd like to develop an infrastructure and a toolbox. I come back to that later. Why the metabolomics? Well, I'd just like to show you this slide because this is a very nice paper, and almost all members of authors of this paper, or quite a lot of them, are member in our project. So we really have the best scientists in this field in our project. So there are already some examples. The IARC has a very nice database which you can look at, the Phenol Explorer. And if you look at that, you can see, okay, let's see how can I assess apples intake. For example, you see that then the levels of camphorol, isoramnitine, fluoretine are higher in circulating plasma or in urine output. So there is already a lot known, but then of course it's what is the validity, what is the quality of this information. Like I said, we use metabolomics. Now, I'm not an expert in metabolomics at all, so we use different methods, but I come back to this later. And like I said, we have very good people in this field. And especially like to acknowledge Dave Wishart, because he's Canadian, but I already had put this slide in my presentation, because he has developed an incredible resource, the Human Metabolome Database, which is really admiring. And then I have to say also, David Wishart was last year with us when we did the kickoff in Wageningen. And I expect, such a giant of research to come to Wageningen, and I expect, a giant to come into the room, and then he's very modest, just in his jeans and his baseball cap, a very adorable person, I would say, very helpful. So, I mean, for me, it was a very nice experience to have him here. And I can say we are very happy that he is on board. What we also want to build on is on existing databases, such as the one from David, but also on existing biobanks of the studies which have been done in the past, which can be observational studies or can be intervention studies with food. So we made an inventory while preparing our grant. So we have a biobank and data available of about 54 human intervention studies and observational data of quite a lot of people. You see that here. And actually these interventions include the various type of foods, so we have at least some biobanks to validate our findings on. Okay. This is the work package. Well, I nicely framed it as a football, and Mary Jo alerted me on the fact that maybe I should explain what is a work package. Well, we are Europeans. We very much are trained by the 5th and the 6th and the 7th framework, so we are used to work packages. So that is how we organize our projects. So I am the PI, the coordinator, and then we have divided the work into different work packages, which each has their own PI, so to speak, who is responsible for organizing the work. And this, I don't know how you Canadians do that. I'm so used to it now. I don't know otherwise, but okay. That's why also we talk easily about deliverables and milestones, which is also from the EU grant applications. Nobody else knows them. There's a work package on discovery, so we're really trying to discover some new biomarkers. I'll come back to this later on this work package. There's a smaller work package focusing on the nutrients. We don't want to leave the nutrients alone. And this one focuses especially on developing new methods of taking blood, for example, using dry blood spots instead of a venipuncture, which is easier to transport and less costly. We have a work package, very important, which is on the validation of the results here, but it also includes a literature review. I come back to this later. Work package 4, where David is in, it's tools and resources, so that are important for the production of our outcomes, so to speak. There's a work package which is more related to the relationship with health, so more focusing on biomarkers, which not only say something about dietary intake, but also a little bit on the subsequential health effects. There's a work package, a smaller one, which is related to the links with policy, and we are focusing on topics like what does it mean in the end for the policy maker, although we start with some science here as well, but that is based on the fact that we like to know a little bit more about the quality of our data, single urine, single sampling versus multiple sampling, and then there's the work package about the coordination. So some selected products for you now. A review article on validated biomarkers for nutrient intake. Policy papers on the impact, one paper on the interpretation of the biomarker range, but also what to do with non-nutrients, food additives and contaminants, because they're part of our diet as well and not part of our main discovery exercise, but we like to include them. And actually submitted manuscripts on improvements and also on the validation of the intake biomarkers for at least 10 important European foods. I come back to that later. The methodology strategy, that's of course also an outcome which is transferable to the future, I would say, and also, well, related to the education of the young people. The food metabolome database, which will be hosted by Dave Wishart, and a protocol that's also related to the policy seeking permission for data mining, because actually, that's especially in Europe, but you have these privacy issues in Canada as well. We have nice biobanks, we have nice intervention studies going on, and the data are stored, the biobank is there, but how can we assess those samples? That's not always easy. There are rules and regulations related to that. So, and they are different in different provinces, they're different in different countries. So this is the protocol. Okay, the status, we started in December 2014, and the kickoff meeting was in 2015 in Wageningen. I'm from the University of Wageningen, by the way, which used to be an agricultural university, so I know something about agriculture, but now is more into the life sciences. We had an annual meeting together. We do it in a cheap way, together with another meeting, so where the half of the people already go there, so then it's easier to team up with it. And the next one is organized by Lars Overdragstedt from Copenhagen. He will host it in September. And of course, we have regular telephone conferences. Okay, work package 1. That started with an inventory of selected foods, and actually we now have 12. And then for acute studies, really to find out new biomarkers or potential biomarkers. So, and it also develops standardized protocols. So this work package already finished one acute study. That was very nice. That was the Swiss group. The work package 3 started with literature review on 12 different foods, food classes, I would say. So this will come out, the reviews will be ready, systematic reviews will be ready after the summer holidays, I guess, and will be sent in for publication, so that will for everybody to read. Work package 4 developed a website, and we started with the consortium agreement, which is also an issue, but I won't go into detail now. Work package 1 is led by Lorraine Brennan from Dublin. One of the targets is to identify novel biomarkers for dietary intake for the top-ranked foods. We first looked into, and then there's a subtask leader. That's how it works in Europe. You want to try to link everybody or feel everybody accountable for some part of the work, so that's how we try to organize it. So we had a list compiled of foods which was requested for by all partners, and actually these are the list of foods, you can see that here. So we have centers, they said, okay, I'd like to focus on a tomato, and we said, okay, tomato is a vegetable, important for public health in Europe, so okay, let's go and continue with the tomato. We have milk and cheese, which is done by the Swiss, apples, sugar-sweetened beverages, important as well, and of course, like I said earlier, people with overweight tend to underreport some particular foods, and the sugar-sweetened beverages are definitely underreported, is our experience. Carrots and legumes, red meat, potatoes, bread, meat, lentils, chickpeas. So there's a list of selected foods, and they are from the food classes we think are important for public health. There's an overarching standardized procedure. What we did now is that we did a randomized crossover study to tease out this biomarker. So you have a food A, a food B, and a control food. So for example, the Swiss, they looked at commercially available food milk, full-fat milk, and commercially available Swiss cheese. And the control food was a soy milk. Yeah, so that is their test setting. And every individual was randomized to a certain order of these three foods. Overall, they had 50% of male, 50% of females, aged 18 to 14 years, normal body mass index, I would say at least non-obese. They used to drink milk, so you don't want people who are lactose intolerant, and no adverse effects after an intake of, quite acute intake of 600 ml of milk. So this is the schedule, what they did. At the first days, you have the elimination diet, a specific diet where you are free of this type of food so that you haven't eaten them. And then on day 2, you give the test food A. And then in this day, there's multiple urine sampling. all over this, so we can follow the course over the day, what happens with the metabolites. And of course, there's also blood sampling, which is a little bit less often. There's a washout period, and then again the other food, and then again the other food. So that is what one single subject has to undergo. So that's for one subject not too intensive, but of course he needs to be one whole day in the lab for the sampling. Now the protocol is finished, and the people from AGROSCOPE, they are really finished their study. So they are the first one to finish. The other ones already started or are supposed to start within the next month. So it's really going very well in this. And just to give an example about the collaboration, for example, we have the food, the cheese, for example, and we have the analytics of the food. We test the food with the same metabolomics criteria or method, but also, of course, we analyze the urine and serum or plasma for the metabolites. And for the cheese, for example, the AGROSCOPE, the Swiss themselves, they test the food, they do the food analytics here, but also some NMR on the food is done by the Italians, right? The Italians have the NMR, so the food is sent to the Italians for measurement of the NMR. And for the banana, it's run by the French in Clermont-Ferrand, Claudine Manard. And then they have this also in INRA, the measurement of the food, urine and serum using the LCMS method, for example. And then again the GCMS, which is in Germany, and then the NMR, which is run in Italy. So it's a nice example of how we can combine all the tools available, experience and machines available in the different expertise centers. So we just send the food and the samples around, which works quite nicely, yes. And one of the outcomes of this is how everybody does this, so we write that down, so we also make sure that the standard operating procedures of all the methods are being noted down and aligned as much as possible, and also can be published later. So this is really a great progress in Work Package 1. Work Package 4, I think, is interesting for you also because that's a tool and resource work package. The main objective is to develop the missing tools and online researchers so that resources so that we can use our results also later and also open for the other scientists and organize the sharing of the data and these resources. We now have the Food Metabolome database, version 1, hosted by Dave Wishart in Alberta. It now consists, sorry, I always take the wrong one, about 26,000 food constituents with their dietary sources, more than 900 dietary sources, and a lot of separate data fields with the composition, with the biochemical and the information on the physiology. So at the moment, it's already the largest and most comprehensive food metabolome database. It's hosted in Canada, so I didn't know if you were aware of that, but you know, we need to applaud you for investing in this because I suspect a lot of money went into this, and it's very, very useful. And during the course of our project, we'll make a new version 2.0. We also made in this work package the website foodmetabolome.org, so you can find all information on our project as well as some of the more details about the toolkits and the resources which are already available on this website as well. Actually, this was my final slide. I'd like to thank all the work package leaders. I'm happy to answer some more questions and details about some of the projects. But not without saying thank you to the ones who invited me. And of course, I'm very happy to share with you our tulips. I know there's a tulip festival next week. These are our tulips, you can see, because it's our windmill. But I also realized that we send Ottawa every year 10,000 of tulip bulbs. I didn't realize that. I only found out because Ashley sent me the link, because our queen, our former queen, had lived here during the Second World War, and our Princess Margriet was born here in Ottawa. Actually, I knew that, but somehow I didn't realize it, but I do now. So thank you very much, and we keep up the good collaboration, I would say. Thank you.
Questions or comments for Edith? Yes. Maybe you just introduce yourself.
I'm Carolyn O'Brien. I work for Canada Bread.
Okay.
and I'm a dietitian and with the University of Toronto Program in Food Safety. And I'm excited to be hearing about this. I'm just wondering, curious, because bread was on your list.
Yeah.
So the samples that you take
Yeah.
of bread,
Mm-hmm.
are they commercial? Are they
Yes.
made?
I'll check. Because actually that's one of the details I couldn't remember, but I'll check what they said about. No. Wait a second. At least they are commercial. And at least what we do is it the same way we do it for making our national food tables, the databases. So that's, multiple sampling. In this case, it's not multiple sampling, but it will be a well-described type of bread. And that's a little bit tricky thing because of the big variation in types of bread and the wheat or the rye or whatever. So what we can only do with the amount we have, of the amount of money we have, is to test one bread, for example. Yeah, not too many other ones.
So it would be the same type of sampling as far as the participants that are in there. They would all be healthy individuals.
Yeah. Yeah, from the other one is the same as what I described for the Swiss study who did the milk and the cheese. So this is a similar protocol for every test food, but the test foods are done in a different center and also with different participants, but the inclusion and exclusion criteria are exactly the same. Yes, and the protocol for the blood test.
Do you have any involvement of the industry participating?
No, that's a good point. Yeah, we don't have actually. It's not that we don't allow them. At this time, it was, we never discussed. I think for the Swiss, there is some involvement of the industry, but then actually I don't know this officially. It's not a secret, but it also depends on the local circumstances, I would say. This is really possible, but actually I don't know that by now, that of course the Swiss cheese has been given by some of the Swiss industries, but that's, not even necessary, because you have to realize it's not that big amount we are testing. It's just in 12 participants, so it's quite limited. But it will give us a good flavor because it's on a standardized way, the standardized protocol and the standardized measurements. So that is really a big topic in the metabolomics, that it really needs to be standardized, or at least described well. And it gives us a lead for further research, of course, because this is really let's say, a project which will not really come out with policy recommendations in respect to food and health, but more with recommendations for other researchers or for methodologies for developing this field.
I'm fascinated. I believe it was just starting in 2016 with bread factories, so it's something.
Sorry, yeah, I use the microphone. Yes, sorry, yeah.
So it's only initially starting.
Yeah, exactly. So the bread, yes.
Much there yet.
No, I think the bread data will be there by the end of the year. Yeah, it will not take the whole period. The project is for 3 years, but so we are almost halfway. Yeah, by the end of the year we should have the bread data. I'll check for you who is doing this, because I don't know by head. Yeah.
Okay, thank you.
Yeah, you're welcome.
Another question here, David.
Thank you. Some really high-powered tools that you're employing in this project. So I'm just kind of curious, going back to one of your earlier slides,
yes,
about the correlation with 24-hour FFQ,
oh, really?
etc.
No, I know.
Curious if you had a sense, where does metabolomics rank?
Yeah, we don't know that yet, right? So this is I will tell you where it is. Here, yeah. What we hope to find is that we use now, this is an example from protein, and then gold standard is urinary nitrogen as a gold standard. What we hope to achieve with our metabolomics for food, that we can make a same table, but then have a gold standard for the food, like the bread, our metabolomics results from the food. So that should be available for the gold standard. And then in validation, you can compare your other less well assessment methods, intake methods, for the correlation here. So the idea in this case is that it can be a very good gold standard for estimating the food intake. But on the other hand, if the methods are becoming cheaper and cheaper, at the moment they are quite expensive, and also, with the LCMS you get metabolites which you don't even know what they are. So, I mean, there's a lot of developmental work needed to find out what components are there, so that's a lot of unexplored territory. But when we know them, and when the cost of this are getting down, or where you can develop tests which are, much easier, then of course you can also use it really in large databases or in larger studies for dietary assessment. But the first application I see is as a gold standard, or more or less gold standard, for studying the validity or the relative validity.
A follow-on question
Yeah.
about, in the metabolome,
Mhm.
given food,
Yeah.
are you looking for a unique chemical
No.
that's associated with that
Yeah.
food, or a fingerprint
Yeah.
of that?
That's a very good point. It would be nice if it's unique, but it's probably not very difficult. So now I found out for the bread, the Germans are using toast, a specific defined toast, which is available from the supermarket. But of course, if you find something specific for toast, it's very difficult to foresee, because you get, then it shouldn't be there in the brown bread or in the wheat bread. So that's, it will be fingerprints, probably. Yeah, but that's also something to explore now. So that is the important outcome of our project. To what extent there is really overlap, or to what extent we really should use the fingerprints. But that's more likely, I agree.
Dr. McBurney, you get the final question.
DSM, Michael McBurney, DSM Nutritional Products. The earlier speaker, Dr. Burns, talked about the disconnect between the ministries of science, sort of, and the science and technology. Is there an opportunity to sort of back down into just looking, metabolomics is really interesting and will have future potential, but to do something just like we've done with vitamin D, to be able to measure serum vitamin D status and identify whether people are at risk of insufficiency. And then there's so many opportunities for the food manufacturers and the retailers and others to be involved in these solution providers once we really know whether a population in a location is insufficient or not.
Yeah, true. I think it's possible in the end, well, at least now, of course, it's already possible to ask people about vegetables and fruit, and we know that, and I'm sure it's in Canada the same, that people don't eat enough vegetables and fruit. So sometimes, this is for public health, it's easier just to ask a quick question than to have an extensive measurement. And for vitamin D, of course, it is important to look at the blood, because with dietary intake, it's only a limited information you get about the vitamin D status, because the other rest is from the sun. So this is a little bit different for this type of products, I would say, although I can envisage that when you are a doctor, and you can say, well, like I said, for some people, it's not easy to recall what they have eaten, like I said, the children or the elderly people with some memory complaints. So in some populations, it's easier or better to go into biomarkers than in others, probably. So I can envisage a method that the biomarkers will become more and more important, also in the more clinical or subclinical situations, for example. And then you can use this information while, with updated or improved laboratory methods to get more insight into that. Yes, that's true. Thank you.